Look past the interface, past the user experience. Today, we're uncovering the hidden architecture of modern networks. We're looking at the structural forces that actually dictate how complex systems behave, often despite our best intentions.
There's a universally accepted belief that we build all of our networks on. It's the idea that removing communication friction naturally increases human understanding. You know the logic. Making it easier and cheaper to send information is just supposed to naturally lead to better communication, right?
But that assumption is entirely false. Removing friction from a system actually doesn't improve it. In fact, eliminating the structural cost of transmission mathematically guarantees the collapse of meaning. It's a bold claim, I know, but the math doesn't lie.
Just look at the most basic observable consequence of this contradiction. 294 billion emails. That is the volume of emails sent across the globe every single day. That's a truly disturbing, almost irrational quantity of data. It's not a glitch, though. It's a symptom of a deep structural force quietly operating in the background of our lives.
Part 1. Rational optimization of noise.
Let's picture a simple physical system. A solitary steel bearing is dropped. It strikes a bronze plate. The impact produces a distinct, clear acoustic ring. You hear it, your brain processes it, and then it fades. It's a perfect transfer of a signal.
Now, think about our digital architecture. The infrastructure we've built essentially distributes the cost of that strike. Transmitting a message today requires practically zero resources from the sender. The physical friction of dropping that bearing has been completely removed.
And because the cost to send is zero, the incentives of the entire system fundamentally shift. Think about it. Even if only 1 in 100,000 recipients actually responds to a mass message, a microscopic conversion rate of 0.001%, mass transmission is still highly profitable. Since the structural cost of sending is zero, sending as much as physically possible is simply the most rational, perfectly optimized strategy a user can adopt.
So what happens to our physical system? Well, because the drops are free, thousands of steel bearings are poured onto that bronze plate all at once. Those individual, clear acoustic rings we had before, they merge. They become a sustained, deafening physical roar. The signal is completely gone.
Part 2. The filtering arms race.
As that volume escalates, the network begins to fracture. We're witnessing a complete structural inversion. Historically, information was the scarce resource, and our capacity to consume it was abundant. Now, the network produces infinite information. That scarcity constraint hasn't disappeared. It's just migrated entirely from the production side over to the consumption side. So here's the overwhelmed endpoint, the receiver, drowning in this roar. Their local, entirely rational response is to deploy automated filters. They start building digital barriers and complex sorting mechanisms just to block the incoming flood. They're desperately trying to isolate the signal from the noise.
But remember, the senders are also rational actors operating inside this exact same structure. To bypass those shiny new automated filters and guarantee their signal actually penetrates the barriers, senders have to structurally escalate their behavior. They aggressively multiply their volume and frequency, sparking a continuous, unyielding arms race.
Our attempts to organize all this data actually end up compounding the structural breakdown. What we're witnessing here isn't just information overload, it's filter failure. The very tools we built to manage the noise become the exact reason the noise has to increase.
Part 3. The constraint of attention.
This whole system is continuously accelerating, completely blind to the hidden, fixed boundary it's colliding against. And this brings us to the core physical constraint of the entire architecture. While the digital network can generate infinite signals at zero cost, the recipient on the other end is biological. Human cognitive processing bandwidth is strictly physically limited. It simply cannot scale.
This is the attention economy. It's a profound structural shift where the network no longer values the actual data being sent. Instead, it extracts value directly from the cognitive limits of the receiver. Your focus, human focus, is now the scarce, finite commodity being actively mined.
The cold logic of this mechanism is absolute. A wealth of information inherently creates a poverty of attention. To put it simply, the system consumes and depletes the exact biological resource it relies upon to function in the first place.
Part 4. The architecture of lock-in.
Let's go back to our physical system. That bronze plate is no longer just ringing, it's buckling.
Under the continuous, deafening mass of high-frequency vibration from those endless steel bearings, the plate sustains deep structural damage. It literally becomes immobilized by the sheer mass of its own activity.
For the biological receiver, for us, the filters have completely failed. The cognitive bandwidth is depleted, and the only effective defense mechanism left on the table is total withdrawal. But here's the catch. Disconnecting entirely simply forces the user out of the functional system. Sure, you block the noise, but you mathematically guarantee your own isolation.
So, what does this all mean? The collapse of meaning, the billions of emails, the deep cognitive exhaustion. None of this is a glitch. The overwhelming noise is actually the system working perfectly. It's the inevitable mathematical conclusion of removing friction.
The network was never failing. It was strictly following its structure. The architecture dictates that perfectly rational local optimization, like sending free data, building automated filters, and fighting for scarce focus, will always lock the global system into permanent, irreversible friction. When a system removes the cost of speaking, it eventually destroys the ability to hear.